Compound interest. It kind of works our way into the introduction of the exponential constant e, which we'll talk more about. But we have a formula for compound interest that you see above there in the green box. It's also in your notes. So it isn't as though you necessarily have to copy that part down. But you do need to make sure you know what it is, proper setup is, and you know what the letters all stand for. Now this compound interest formula here, this formula only deals with money, okay? Not anything else. So if you're talking about bacteria growth, you're talking about, exponential decay of some sort, this formula will not do it. But when I look at that formula above, a stands for the amount of money you have after a period of time, T. And as you see down second from the bottom, that T is time, typically in years. P is the initial amount. R is the interest rate in decimal form. What I mean by that, when I look at, for instance, example 15 here, that you see 6.9% for the percentage rate, and someone will say, well, that's already in decimal form. Well, we want it written as a decimal only, no longer with that percentage sign being needed. So I have to remember, like, well, if I have a percent, that's like a fraction over 100. So 0.069 would be what we want for the decimal form of that interest rate. And n is the number of times the interest is compounded in 1 year. So basically, when we deal with compound interest, if I have like a 6.9% interest applied to like my balance, it only happens once a year. Then basically, at the end of the year, whatever, if my balance is $5,000 in the bank, then they take 6.9% of that 5,000, add it to that $5,000. When I compound interest, what I do is I say, well, I'm gonna split up this interest rate a certain number of times, depending on how many times it's compounded. And then, and I'm going to divide, and I'm basically going to take that interest rate divided by that amount and apply it that many times. So, for instance, if I'm going to compound it semi-annually, which is twice a year, I'm going to take that 6.9%, split it into two, which would be about 3.45%, and apply 3.45% twice to that $5,000. Well, 3.45% to the $5,000, get a new amount, and then that new amount apply $3,450 at another point in the year and get a new amount from that. And that's why compounding differently will oftentimes cause, compared to only compounding it once, create values that are bigger, because when I do the second compounding, when I do the third compounding, whatever, how many times I'm compounding the interest, the amount I am taking that percentage of and then adding it to the total is getting bigger each time, because I've already grown between the first compounding and the second compounding. So, let's have a look at how these will be calculated. So for interest, for instance, in part A, if I just compound annually, which means once a year, n would be 1. So I have 5,000 times 1 plus 0.069 over 1 to the 1 times 10 power. I get $9,744.22. If I compound it semi-annually, which means twice a year, and the other thing that's going to be different, n is now going to be 2. But you notice when I do that, at the end of 10 years, I end up with, about $109 more. So it is causing a difference. And again, that's because, each year, the $5,000, I applied 3.45% to that, got a higher amount. And then another 6 months go by before the end of the year was up. I'm taking that new amount and taking 3.45% of that, and then adding that value to the value we have in the bank at that time, which is a higher amount than 5,000. Because of that, that's why we end up with more money when we compound. But as you're going to see here, if I go from semi-annually to quarterly, now this means I'm going to compound it 4 times a year. So I do expect it to be higher. But if you notice, it is higher, but when I looked at going from 1 time a year compounding to 2 times a year, it was a $109 difference. When I go from 2 times a year to 4 times a year, I was thinking, well, I'm doing it twice as much. It should be like much more money. It isn't. It's about, roughly about a $60 difference, if that, not even that. So yeah, it went up. It went up more. It certainly still is more compared to what we have when doing it annually. But when I went from semi-annually to quarterly, not as big of a jump as we would maybe expect. Monthly, that's 12 times a year. So n would be 12. Notice here, it's 99.48. Again, still bigger than the other ones, but when I go from now 4 times a year to 12 times a year, I only have a difference of about $38. It seems as though that compounding is going to cause my final amount to be higher, but there's a limit to how much that's going to affect it. So if I do daily, that's 365 times a year. That's the final amount. Hourly. So you see here, I mean, eventually I get to a point where I'm not going to be going much higher no matter how many times I compound it. And that kind of brings up where we need to talk about next. Well, what is the highest amount of money that could be earned from a 6.9% annual percentage rate? Because sometimes you're asked, like, what's the highest amount? What we will discuss in part 3.